Today we'll learn what is register. It is used to store the data and operations are performed on the data stored on it. Operations performed on it are known as micro operation. For an example, shift, count, clear, load, etc. Now registers, they allow storing of data in very minimal amount, and even register have the data capacity. We also have different capacity of the register for the data storing, and the operations that are performed on it are known as micro operation. Capital letters are used to denote registers, and sometimes capital letters are also followed by numbers. For example, R, R1, IR, PC, etc. I have noted some of the names here. For an example, MAR stands for memory address register, PC stands for program counter, IR stands for instruction register. Now, these three different diagrams shows in which way we can show the register, or in which way we can draw the registers. As you can see in first diagram, they have given the first box the name as R1. They have not labeled anything. So in first diagram, the number of bits is unknown here. In second diagram, the name of register is R2 and it is of 16 bit. As you can see here, it is labeled from 0 to 15, so we can say it is of 16 bit. And register can also be represented in this form. So it starts with 0, ends with 7. So basically this is of a 8-bit register. Now what are micro operation? In first slide, we saw that micro operations can be called as operations that are performed on the registers. As the data on the register are very small, we call this operation as a micro operation. Now, what is register transfer language? Copying the content of one register to another register, also known as register transfer. A register transfer is indicated by R1, arrow, R2. Now this arrow can also be known as transfer operator. Now, in this example, we can see that content of register R1 are copied or loaded into register R2. Now source register here is R1 and R2 acts as a destination register. Now this operation, what is carried out here, it is also known as non-destructive, as it will not change the content of R1. It is going to change the content of R2. R1 content will remain the same. If in case we want to transfer the data of a register on a condition, then control function is used. Now control function is a boolean variable, that is, it can be 0 or 1, and condition is terminated with a colon. Now as you can see in the example here, P colon R2 arrow R1. Now which means if P is equal to 1, then and then load the content of R1 into R2. Now if I want to perform two operations simultaneously, I can also write it as the shown in diagram, and both the register operations are separated by comma operator. So basically this both operation will execute in one cycle. For example, if P is equal to 1, then the content of R1 will be transferred to R2 and content of IR will be transferred to MAR. MAR is nothing but a memory address register and IR is instruction register. So as we saw a few of the example of register transfer language, here in the table I have noted different format of a register transfer language, including arrow, colon, and comma. Thank you.